Good morning, dear. Today we will start chapter 8, which talks about perpendicular bisector and bisector. Today we will start with the perpendicular bisector. We studied about this idea in grade 6. It's an easy lesson, but I have to concentrate well. What do we mean by perpendicular bisector of a segment? It's a line that cuts perpendicularly a segment at its midpoint. For example, here you have segment AB. I is the midpoint of AB. How did I know that? Given that AI equals to IB, since the same mark is put on AI and IB, this means that they are equal. So AI equals to IB, then I is midpoint of segment AB. Then D is perpendicular to the segment AB passing through its midpoint I. Then D is the perpendicular bisector of AB. That's how right. I is the midpoint of AB. D is perpendicular to AB at its midpoint I. Then D is the perpendicular bisector of segment AB. The perpendicular bisector of a segment is the axis of symmetry of this segment. What are the properties? The direct property says that every point on the perpendicular bisector of a segment is equidistant. Equidistant means having equal distances from both extremities of this segment. Look here at this figure. It's a segment AB. Extremities means point A and point B. D is the perpendicular bisector of AB since D is perpendicular to AB passing through its midpoint I. Then any point on the perpendicular bisector, here M for example, since M belongs to the perpendicular bisector of segment AB, this means that M is equidistant, having the same distance from extremity A and extremity B. This means that MA equals to MB. The reciprocal property or converse rule says that every point equidistant from both extremities of a segment, then it belongs to the perpendicular bisector of this segment. What do you mean by that? If MA equal to MB given or proved, then we can say that M is equidistant from both extremities of segment AB, then M belongs to the perpendicular bisector of AB. Now, given a circle C of center O and radius R, this is the circle C, center O and radius R. Here radius OA or OB. And another circle C prime of center O prime and radius R prime. The bigger circle here is C prime. Its center is O prime and the radii O prime A and O prime B. These two circles intersect at 2 points, A and B. What's required to prove OO prime is the perpendicular bisector of AB? This is the segment OO prime. I have to prove that it's perpendicular bisector to AB. The definition says if the line is perpendicular bisector of a segment if it's perpendicular and passing through its midpoint. How to apply the properties? Here, for example, I have OA and OB are two radii of the same circle, and we know that radii of the same circle are equal. Since OA equal to OB equal to radius, then O is equidistant from both extremities A and B. This means that O belongs to the perpendicular bisector of the segment AB. Okay, that's how I think. Now, let's look at another side. I can also say O prime A equals to O prime B equals to R prime. Since radii of the same circle are equal, then O prime is equidistant from both extremities A and B, and also I can say that O prime belongs to the perpendicular bisector of AB. Since O and O prime are 2 points that belong to the perpendicular bisector of segment AB, then I can say that the line joining these 2 points, I mean O prime, is the perpendicular bisector of segment AB. How to construct? We have two methods, either by using a set square and a ruler or by using a protractor. Let's see how to draw by using a set square. Draw the perpendicular bisector of AB. First of all, I have to draw the segment of AB. Here, for example, of measure 6 centimeter. Okay, then I know that perpendicular bisector is perpendicular to the segment at its midpoint. Then I have to plot the midpoint of AB. Where to place it? Since I is the midpoint of AB, it's in the middle. So IA equals to IB equal to half of AB. So 6 over 2 equals 3 centimeter. So here at 3 centimeter, I can say that AI equals to IB since I is the midpoint of AB. Now we found the midpoint of AB. I have to draw the line D perpendicular to AB passing through point I. Okay? Here, perpendicular, that means the lines D and AB form a right angle. We can use our set square in this way to plot it. Okay? Since D is perpendicular to AB at its midpoint I, then D is the perpendicular bisector of AB. Another method is by using a compass. Draw the perpendicular bisector of segment AB. If you don't know the measure of the segment, it's not given. So an easy way to draw is to use our compass. First of all, I have to draw an arc of center here B, and then we draw the first arc. Open the compass such that it's greater than the half of the segment. Then draw another arc of center A without moving the opening of the compass. These two arcs intersect at 2 points. Here I call them M and N. Then I join together these points M and N so that MN now is perpendicular bisector to AB. Okay, as I told you before, the perpendicular bisector is perpendicular to the segment AB passing through its midpoint I. And keep in your mind that every point on the perpendicular bisector here, since I draw the perpendicular bisector, I can say that M is equidistant from both extremities A and B. So I can prove that MA equals to MB and NA equals to NB. Thank you for your attention.